right. Yes, hang on. Alright. Look at that. Should be on. Okay. And done. Hey, welcome. Hey. Alright, you know the drill. You're the first one here. Mic check, audio check. Mic check, audio check, and visual check. How do we look? Mic check, audio check. Check, 1, 2, check. We good? Good, alright. Good to go. We got the lighting ready to go. Yeah. Me. Alright. Thanks for tuning in. Thanks for all your support this semester. Yeah. Thank you so much for your support this semester. Means a lot. Means a lot. I enjoy doing these on Thursdays. I really, really do. No bullshit. Totally like these. Again, I really like these streaming on Twitch because you know what? They're recorded. That's number one. That certainly helps. But in terms of learn, that's important for learning. So you can always scroll back and forth of the video. But the whole idea that everyone have to sit in the classroom all the time, it can be intimidating and it's daunting. Emergencies and stuff happen. So maybe sometimes a lot of times you can't even be in the classroom. All right. Hello. All right, we got 1 more minute. We got 1 more minute. I'll fire up a terminal because we'll need that. I will need that. Hello, everyone. Hello. We got 1 more minute and we're going to start right on the dot. Yep. Oh, a lot of hands-on demo today. Lots of hands-on. Oh, yes. Even finally got, I'm finally using the newest version of VMware Fusion from Mac OS, so I can run Kali Linux on top of the Mac now. Yep. Unfortunately, the bad news is that if you're a student, you can't get the newest version of VMware for free anymore. It's kind of not that good. You got to pay, but at least you get some educational discount for it. All right, hello everyone. Hello. We are back. Welcome to Introduction to Security at Tufts. I'm Ming Chow, Associate Teaching Professor. Hello everyone. Hello. I hope everyone had a wonderful Thanksgiving. It was a week ago. Hope everyone had a wonderful Thanksgiving holiday. We got another holiday. We got Christmas and New Year's coming up very, very soon. This is also the second to last Twitch stream of the semester. Thank you so much for all your support this semester. It means a lot to me. Totally love doing these. And we'll be back for season number 6 in 2023. Today's the second to last course. Now, this is the second to last stream, and although the content is not you don't get quizzed or examined on this, for a lot of students, they find this probably the more interesting streams because it's very hands-on. It's very hands-on. It's also a lot of fun as well. And I want to give you a bit of a motivation. Okay, so I have a disk image here. Actually, before I do that, where's everyone today? You remember on the very first lab that we have in this course was working with the command line. Remember this lab? This is like the very first lab. Hey, Slapcake, how are ya? Okay, good. Someone chimed in, which is good. And one of the questions I asked on the very first lab of this class was, what command can you use to securely delete a file? And if your response was RM without any flags, That was exactly the answer I was not looking for. There's a reason why I asked this question in the first lab, which is what command can you use to securely delete a file? Anytime when you delete a file using straight RM with no flags, or when you put in the trash in Mac OS or in the recycle bin on Windows, you don't securely delete the file. You can actually resurrect it. If you don't want the file to be resurrected, which also means securely deleting a file, you use a command like shred. And what we're going to do today, this question leads up to finally today, is how do you recover deleted files, especially files that were deleted using RM, empty the trash, or just dumped in the recycle bin. And today the big idea is forensics. I'm going to give you a little bit of a primer of motivation here. I'm going to share this disk image, evidence.dmg. I'm going to paste it here. That's the link. This is a link to a real disk image. So I'm actually going to download it onto my desktop. wget evidence.dmg. And here's a little motivation for you. This is a disk image. It's not that big. It's only 50 megabytes. There's only 50 megabytes here. I have a copy of a disk, like a disk drive or USB, here in this DMG file. If you open it up on Mac OS right now, you can double click on it. And you can see a copy of the disk drive right here, evidence. When I double click on evidence, I double click on this drive, how many files do you see? How many files do you see here? You only see two. There's a TXT, hey Chang Hot. There's only two files. There's a TXT file and a picture, WebP. You only see two files. Now, just to let you know, just to prove that I'm not playing tricks or there's any hidden file, let's really look carefully at the hidden files. Plus two hidden okay, whoa, are there two hidden directories? I'm not sure. Let's double check and done. Hey, RZ. I'm going to CD vol, which is like all the volumes on this Mac, and I'm going to CD evidence. You sure? Okay, there's only two files, but if I do an ls, same, you get the two files. You can do a cat stack.txt, and then you get a C program of some sort. But let me do an ls minus L now. There's two files. But if I do I'm going to clear the screen and do an ls minus LA. Let's see how many files are there really. Alright. There are temporary item trashes. There's a ._stack.txt, which is really like a backup copy. It seems like a backup copy or like a cache version of stack.txt. There's a ._x7 of this WebP, this picture. Yeah. So on the ls minus LA, you see one. Okay, let's give a nice number. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 files. There's 9 files in this on this drive. Okay, I think take a visual snapshot of this. There's only 9 files. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's 9 files. That's it. So I'm not playing any magic. There's no magic tricks here. So the question is now we're very clear that's only one text file, and there's only one image file, one picture, which is a .jpeg.webp. Yeah, let's do that. RZ27, RZ, let's do that. Let's count the dot and dot as files. Let's do that. Let's do that. Let's count those as files. Let's do that. The question now is that it? You sure? Is it only like, is this only at most 9 files here? Is there any more stuff here? You see one text file, one picture. You sure that that's it? Is there anything else? Are there any deleted files? Are there any files? Are there any files here? Are there any additional pictures, especially like deleted stuff? That's what we're gonna do, and that's what we're going to do today. Again, now I'm showing you this. No magic tricks here. You see there's 9 files here. Yes, that also includes the dot and the dot dot. Are there more than that? Also, in addition, like, can we recover the files that got deleted off of this disk? Can we do that? And that's what I'm gonna do today. Hey, Crispy Nugget, maybe. Actually, hopefully the answer is not maybe, but yeah, we will. But keep this in mind. So I'm just going to give you now a little primer on forensics and incident handling. So what we're going to do today is we're going to do a couple of nice hands-on demos. I'm going to teach you how to use DD. We're going to acquire data from a disk using DD. A disk is like a hard drive, a USB stick, or an external hard drive, SD card. Okay, we're going to analyze that image from DD using forensics tools such as Autopsy, SleuthKit, and Foremost. And we're going to recover deleted files off of this. That's what we're going to do today. That is our goal. This is our goal. We're going to use a series of tools. So, imagine, and so far in this whole security class, we've done attacks. We've done malware. We've even done malware as well, too. But the scenario is, okay, imagine that you have been attacked, compromised, or involved in a criminal incident. What was it? For example, I'll just give you one right now, which is the one that's going on at this moment. As if anyone's a sports fan here, if anyone's been following ESPN, the backup quarterback at the University of Florida got caught with child porn. What's the evidence? What happened? When? Who was involved? And these are the big questions that typically you need to address in a forensic situation, in a forensics case. Okay, look, people get hacked, people get compromised, people have data stolen all the time. You even get involved in a criminal incident. Okay, so if you're going to be an investigator on the scene, you gotta answer the who, what, when, where, why, and leave no stones unturned. So, what is forensics? So, there's a lot of similarities with like the forensics that you see on TV. You know, what computer forensics boils down to is the preservation of computer media. Computer media can mean hard drive, USB stick, memory, list goes on. The identification of the media, the extraction of content, the interpretation of the findings, and documentation, and a lot of times get presented in the court of law. This is forensics. So preservation, identification, extraction, interpretation, and documentation. Okay. So the process boils down to, assess the situation, acquire the data, analyze the data, report. So, little unknown factors on a need-to-know basis. I used to do work for law enforcement back in the heydays. I want to give a shout out to the HTCIA for all their tutelage and all the support for many years, especially early in my career. Before you go and assess the situation, you gotta obtain a search warrant first. And in Massachusetts, here's how an application for a search warrant looks like. Yeah. And that's an example of a search warrant that gets signed by the court of law. What is interesting about the search warrant is on the back page is a list of all the items, inventory of items that you find. Hardware, software, you name it. Everyday inventory of findings goes here. Typically, you go more than one page. Okay, so before you go and go gung-ho in an excessive situation, you got to get a search warrant first. Got to get a search warrant. So it's not just some basic terminology here. Some basic terminology. There's volatile data, which is like RAM, processes. Also, there's also not, but this stuff changes all the time. Volatile data is a pain in the ass to work with because they change all the time. If you actually are at a crime scene and you see a computer that is powered on, what's the worst thing that you can do? The worst thing that you can do is just to pull the damn plug in the back of the computer. Yeah, that's one of the worst things that you can do because then you lose like login, you lose memory, you lose running processes. One of the worst things that you can do is just yank the power cable off of a running computer if you're at a scene of a crime. Non-volatile data, oh shoot, you know what? Here. Aha. So I have the non-volatile data, stuff that the physical side of things. This is like hard disk, USB drives, okay, phones, okay. So yeah, I mean mobile devices are huge, had a huge spike in those for investigations as of recent. There are two types of acquisition that you can make on volatile and non-volatile data. There's physical acquisition, which is a bit-by-bit copy of the entire physical store, which is like a Samsung hard disk like this. There's a logical acquisition as well, too. You can do a bit-by-bit copy of certain files and directories on a system. So I want to ask you, so what's the difference? What's the pros and cons of using physical over logical? The thing about physical acquisition is, the good news is, you get a full bit-by-bit copy of the entire drive. The problem is, it takes a long time. This is a 2 terabyte hard disk here. If you're going to do a bit-by-bit copy of 2 terabytes, that's going to take hours, if not days. Back in the heydays, like 80 gigabyte hard drives were like considered really big. Remember doing a bit-by-bit, if you did a bit-by-bit copy of physical acquisition of the entire 80 gigabyte drive, it would take like 6 hours, 6 to 9 hours. So it takes a long time, but the other thing is, there's also lots and lots of data you will have. You'll have access to everything. You'll get a copy of everything. The thing is, do you actually need all that stuff? Then you're just dealing with needle in a haystack problem. Logical acquisition is, instead of getting a bit-by-bit copy of all the stuff of a physical side, you only want to get bit-by-bit copies of certain directories and files on a file system. A good example is this, Android. If you want to do, look, I only want to care about certain folders and files. It's just so overwhelming to deal with the entire bit-by-bit copy of the entire Android system. So I only want things in certain files and folders. The good news is, it's a lot smaller haystack to work with. The bad news is, of course, it takes a lot shorter time to actually get bit-by-bit copy of directories. The bad news is you don't get everything, okay? So there may be stuff that you're going to be at a risk of making copies of certain things. A write blocker is a physical device, okay, that allows acquisition of information on, let's say, a hard drive, like a physical drive like this, without any possibility of anything being written to the drive. So if you are actually trying to make a bit-by-bit copy of a physical store like this, one of the things that you hope doesn't happen, especially when you're dealing with a running system, is you don't want data to get in or out when making a copy of the drive. I'll give you an example. So let's say that a target computer that you're trying to do an investigation is actually a part of a botnet. It's part of a botnet and it's being controlled by an attacker in some remote country. And once the attacker realizes that investigators are on the scene are making copies of oh shit, you know what? The cops are here. We got to blow away the drives. And then at that time, if without a write blocker, an attacker can just wipe out an entire disk, and therefore just slowing off your investigation. A write blocker actually prevents any writing that also include deleting of stuff from a disk while you're trying to make a copy of it. Write blockers ain't cheap. So here's a copy, or here's an example. Here's how a write blocker looks like. Here's how write blockers look like for forensics. Here we go. So it's a device like this. You plug you need a power cable. The drive that you're copying to somewhere here, and then another line coming to the drive. There we go. Write blocker allows read-only access of a physical drive without compromising data integrity in any way. When used properly, write blocker guarantees that the data inside the digital storage must remain intact, so nothing gets blown away. There's so many. I mean, these can cost usually 2 to 5, hundreds of dollars. Here's another one. Okay, so it looks like this in this picture here. There is here's a Tableau write blocker. A USB stick is probably being copied in. Power. This line goes to the disk, the writing disk that's making a copy of this USB stick. Okay. So these are write blockers. Write blockers are really, really important for forensics, especially if you want to make a copy of the drive and not have the drive being damaged by it in any way. Chain of custody. I call this cradle to grave process of chronological documentation from warrant to seizure, custody, control, transfer, analysis, disposal. So it's a cradle to grave documentation process. When you're doing documentation for forensics projects, chances are, assume that you're going to be called in a court of law to defend your writing. Okay, what could possibly go wrong if you don't use a write blocker to acquire evidence data? We already talked about that. We already also talked about the pros and cons of gathering physical versus logical acquisition. When would you want to use one over the other? There's a bunch of forensics tools. There's a lot of forensics tools that are out there. A lot of them you are already familiar with. And this is why this is the final topic of this class. What if I told you that even the most famous the big forensics tools, they're all based off of things that you already know. Strings is your friend. MD5, SHA-1, SHA-256, the hash algorithms. DD, we'll see in a few minutes. FTK, EnCase, SaluteKit, and Autopsy. These are the big forensics, computer forensics software suites. And they're made, how they work under the hood is all the tools that you already have, a lot of tools that you already are familiar with. Okay, EnCase is commercial. It is almost considered like the de facto forensics suite that is used in law enforcement. Okay, like thousands of dollars for a license. Steg Detect. Steg Detect, if you remember if you've played our Capture the Flag game this semester, there was a steganography challenge. Okay, and we'll also use Foremost later today. So, forensics tools that you'll see, like we're going to use Sleuthkit and Autopsy today. It's based that they use strings, CD, all the Linux commands, all it often. So here's demo time. So we're going to cover DD, Sleuthkit, and Autopsy, and Foremost. And we're going to hopefully uncover all the deleted files in that disk image. So, this is all I have in terms of slides. So now, let's have some fun. Alright, so I'm going to clear the screen. I'm going to CD into my home directory. I don't think I need the web. Actually, I do need the web browser, so I'll just put it there. I don't need this. We're gonna got along. We're gonna throw that in the trash for now. Okay, so let's say for the sake of argument that I have a physical drive. I want to make a bit by bit copy of this drive. Okay, to make a bit by bit copy of a drive, like a hard drive, a USB stick, an SD card, you would want to use a tool that does, bit by bit copy of it. And DD is the way DD is the way to go. It's also built into most systems. So my question to each and every one of you is, what do you think DD stands for? 2 Ds. Anyone here? Without no cheating. What do you think DD stands for? Actually, let me plug this in. Let me plug this USB stick. I mean this yeah. It's USB 3. Oh. Yeah, where's the thing? Yeah, Dunkin' Donuts. Oh, I want to connect this to my Mac. Okay, so I have a copy of the media drive. Okay, disk to Paul. That's a lame. This is a trick question? You bet it is a trick question. Oh, you bet. You bet it is. What if I told you... No, actually, what if I told you that DD stands for convert and copy? Wait, what? Yeah, DD stands for convert and copy. I kid you not. Man, DD. Convert and copy a file. You may be wondering why the tool to convert and copy a file is not CC, but DD. And here's the reason why. Back in the heydays in the 70s, where people would, when the developers, the creators of Unix, they didn't like to type. How they type was 2 fingers. That's why a lot of the commands that you use, that you're familiar with these days, are 2 characters, like CD, LS, RM. What else? MV. 2 fingers. So, okay, but why is convert and copy not CC? Well, here's the reason why. Because CC was already taken. If you actually you probably have used it. CC is also the C compiler. Now is better known, of course, when it's now Linux land, it's called GCC. CC is taken. So it's like, oh crap. So, okay, so we can't use CC, so that we'll just go a letter up, which is DD. So convert and copy a file, DD. Okay? So how DD works is actually pretty simple. It is pretty simple and rudimentary to use. The DD utility copies the standard input to the standard output. Input data is read and written and 512, and this is important, input data is read and written in 512 byte blocks. This is a very important point. If input reads are short, inputs from multiple reads are aggregated to form an output block. Yeah. Why not Cocoa? Cocoa is too long. Cocoa is too long. 4 characters. The shorter, the better. That was it. I don't want to type. No one wants to type more than 2 characters, or 3 characters for that matter. Okay, 3 is probably the most we'll go. Okay? Well, of course, that also begs the question, why did they actually make a change mod 5 characters? Yeah, I don't know. Is there already some commit? Yeah. The C compiler. There is. CC is a C compiler. I kid you not. There you go. CC is a C compiler. Alright. So how do you make a bit by bit copy of a drive? Like the USB stick, the USB external hard drive that I have. Well, before we do that, we gotta actually get the name of the drive to copy from. Okay, so if I actually, well, first of all, let me just cd/volume. Okay, cd media. So this one have all sorts of garbage. This external hard drive have a lot of stuff. Okay, however, it's not just as simple as dd, okay, and then the meat, and then that's not how it works. What you got to actually do first is to get the actual name, the path, the device name. Now, how you do that on Mac OS land is this. Sudo, you're going to use a tool called distutil on Mac OS. Oh, man, distutil. Distutil is to modify, verify, and repair local disk. Okay, distutil manipulates the structure of local disk. So what you need to do first is get the actual path and the actual name of the USB hard drive. So you do sudo distutil list. And here it is. It's not /dev disk0. Nope, that's not what we're looking for. /dev/disk3. Nope, that is my physical hard drive that's on my Mac. This is what we're looking for here. The external physical drive. This is the actual name of path of the device. 2 terabytes, here we go. That has 2 different partitions. So how you use DD is this. I'm going to make a copy of, I'm going to start to make a copy of this 2 terabyte hard drive. Don't worry, I'm not going to actually make a direct copy of this full 2 terabyte copy. Go to my desktop. So how do you actually do a complete bit by bit copy of, well, this hard drive? It's sudo dd if equals /dev/disk4, which is the actual name path of the physical external device. Out file of equals disk. And you can give it an extension, like you can give it like a .dd or .img. And that's it. So it's sudo, you have your sudo dd and followed by 2 arguments. The input file if equals, and then out file of equals anything that you want, which is like this.img. I'm going to hit enter. It's going to start to make a bit by bit copy of the entire disk here, and 512 byte blocks. I'm going to hit Control-C. Alright. So, number of records in, bytes transferred. Here you go. How big is this thing? It is already 500, and just in a few seconds it made 584.3 megabyte copies of this drive. Not the entire drive, but 584 megabytes worth. if you want to speed up the process, if you actually do a man DD again, just look carefully. Input data is read and written in 512 byte blocks. You want to speed up the process and do much bigger blocks, you can. Oh, you have to set the what they call the BS, block size, to n number of bytes. You can also set megabytes as well too. Okay, if you want to speed up the copy process and instead of using 512 byte blocks, and let's say you want to use a 5 megabyte block, you can do so. Okay. So you do BS equals 5 megabytes. So instead of 512 byte blocks, you do 5 megabyte blocks. So this is going to speed up the process. However, there is a risk. The bigger the byte size is, the bigger the block size that you use, the chances are you may actually may run into issues of missing stuff, including corrupted, like missing like corrupted sectors and stuff. So although you speed things up, you may not get everything. It's not, the bigger the block size, the less accurate it is. I'm going to hit Control C. So now it's 5 megabyte blocks, and now we got 2.89 gigabytes in just a few seconds of copying stuff. Okay. So now I have showed you how to make a bit-by-bit copy of a disk drive. So if anyone ever used Raspberry Pi, if anyone ever has a Raspberry Pi and ever needs to create an SD card of the operating system, yeah, there's a GUI way, there's a graphical interface that you can use, but if you don't want to use a graphical interface, you use DD. Okay? So what you can do is very similar. So the input file is going to be the .iso image of the operating system download, and your output file is going to be actually the name of your physical device. Yep. So that's how you actually make a bit-by-bit copy of a disk drive. So now I'm going to take this disk out. Back. So yeah, DD, convert and copy, bit-by-bit copy. Everything. I'm not going to need the terminal anymore. I'm going to do the trash. Okay. But now, imagine we have a bit-by-bit copy of a drive. Now it's time to use Sleuthkit, Autopsy, and Foremost. Now I have Kali Linux running on top of my Mac now. Yes, I got the newest version of VMware Fusion, which works on the new Macs now. I have a Linux shop. I don't need this anymore. All right. So much is built in. All the important forensics tools are built into Kali Linux by default. Autopsy, Sleuthkit Suite, Foremost. Oh yeah, they're all file carving tech. Yep, they're all here. So, the first thing I'm going to do now is I'm going to make a download of our evidence drive. Here we go. Here we go, 50 megabytes. There we go. Evidence.dmg. Yes. We have a copy of the evidence that we just downloaded. So now, let's try to do, an evidence.dmg was created by way of DD. So now let's analyze this disk image that we just, had a copy of. And let's uncover all the deleted files. So what we're going to use is Sleuthkit and Autopsy. So what is Sleuthkit and Autopsy? Sleuthkit.org. Sleuthkit and Autopsy. Sleuthkit is a collection of command line tools and C library that allows you to analyze this image and recover files from them. It is used behind the scenes in Autopsy and many other open source commercial forensics tools. SleuthKit and Autopsy are free and open source. Autopsy is the front end that uses SleuthKit. So they work in tandem. Now here we are. So how would you do this? How do you run? So you do sudo autopsy. Actually, hold on. How do you do? I'll clear the screen. Yeah, SleuthKit. Right. But there is autopsy though. Man, autopsy. Autopsy forensic browser. Okay. You have to run autopsy as root. It will open up a server at port 9999. Accepts connection from localhost. So, let's start our investigation. Let's use SleuthKit and autopsy. Sudo autopsy. Here we go. Nice, it works. Autopsy forensics browser. Here it is. Open an HTML browser and on the remote host and paste this URL in. http://localhost:9999/autopsy. Let's do that. Keep this process running. Don't kick out of it. Don't Control-C out of it. Autopsy. Alright, there you go. You get a warning, say browser has JavaScript enabled, but you don't need JavaScript to use Autopsy, and it's recommended to turn it off for security reasons. Okay, nice logo. So now, let's create a brand new case. Case number CS116 2022 1201. Description. And I need an investigator for this case. I have Chang Hot 6. I'll also have RZ2750. Ginger root. Yeah. So I'll have some investigators. You're all the investigators on this case. Also Vibs. New case. Create a case. Create case directory configuration file. Please select name from the case. Okay, I'm gonna have to hurt someone's feeling. I'll just say ginger root. Add the host. Okay. Host name, the name of the computer being investigated. It can be contain numbers, it can be anything that you want. We're going to say drive 1. Description, evidence.dmg. Time zone, an optional time, okay. Time skew, no. Ooh, path of alert hash database, I don't know. A path of ignore hash database, okay. So, what's the point of alert hash and these hash databases? So I'll give you an example. If you're working on a child pornography case, there is a database of hashes of known child porn images. So it's just a list of hashes. You use like an MD5 or SHA-1 of like known pictures. And what happens is a tool like a suite like EnCase, or in this case, Autopsy and SleuthKit, it will actually use that database of known like child porn pictures. It will scan the entire disk that you feed in, which we'll do in a few moments, for any file. If any file that comes up has a hash, okay, this disk does not. This disk contains a child porn pic that is well known. So you don't even need to look at the pictures. You don't even need to look at any of open the content. Just match up the hash, and it's like boom. Yep, we have a match. Uh, so that's why hash databases are important. How they're used. Okay, I'm going to add a host. All right, now we import an image for this host file, the evidence.dmg that we downloaded. Enter the full path. Oh, I'm going to open a brand new tab. pwd/home/defcon evidence.dmg. Okay, got it. We don't need that. That's a double check. /home/defcon/evidence.dmg. That is the disk image that we're analyzing. What kind of a disk is this? What type of file? Is this a image file? Is it for a disk or a single partition? Like single partition, you would use a logical acquisition for. Nah, this is actually a real disk. Import it. Do we want to move it? Do we want to make a copy, or do we want to symlink? I don't want to make a copy of this because I'm not making another 50 megabyte copy of a disk drive. So I'm just going to use a symlink or an alias. It must be, yeah. So I'm going to use, it can be imported from the currently using a symbolic link, also known as an alias. Okay, that's it. We're good. Next. Data integrity. We talked about cryptographic hashes in this course. Data integrity. An MD5 hash can be used for verify the integrity of the image. This is very important to calculate the hash value of the evidence.dmg, because if the hashes don't match, that means that the disk image somehow got corrupted or got tampered with. You want to make sure that, we're going to ignore it. I mean, it takes some time. You can choose to calculate, but just want to let you know that calculating the hash value of a disk image is important for investigation, because, if you actually get a hash value that doesn't match, then you probably have evidence that got tampered with. That's really, really bad. File system details, okay, that's fine. Add, think it's a fat file 16, add. Looks good. Okay. All right. Let's find some stuff. Do you remember, folks, how many files that we saw on the terminal? Remember there were like 9 files on evidence.dmg? Let's analyze. So there's 2 disks that we can analyze. We can do disk or the C colon / C drive. Let's analyze this first one. Start analyzing the volume. Choose the analysis mode from tabs above. Let's do image details. Okay. Keyword search. Well, file analysis looks kind of, this isn't good. That's got canceled out. You want to search for a date. Okay. Nothing interesting here. What's really bad is there's no file analysis tab that is closed here. Let's close this out. Doesn't look very good. Looks like we're shut out of luck, right? Let's go to analyze on, let's analyze the C drive. Ready? Oh, okay. Now we're talking. We got metadata, image details, FAT16. Metadata. Okay. All right, but let's do file analysis now. Here we go. File browsing mode. In this mode, you can view files and view directory content. I think remember there were 9 files that we saw? in on the Mac side of things? Let's take a look now. Oh shit. Whoa. What the hell? Alright, remember stack.txt? This is the dot underscore stack.txt file. This is a dot underscore .jpeg.webp that you saw originally. But now you're also noticing a lot of red here. What do you think the red means? Oh my. Oh my. What do you think the red means? Here we go. No. Red means deleted files. Anything that's in the red is deleted files. I don't think you didn't see, we didn't see these first time around. More. Hold on, there's more. Here's a hell of a lot more than just 2 files or 9 files here. Whoa, there's even another text file here? This is cool. Yeah, all the stuff in red on Sleuth Kit and Autopsy is all deleted files that we can now recover. We're seeing a lot of stuff we didn't see originally. The hell of a lot more than just 2 files here. And this is stack.txt. It's the WebP. The web picture. Oh yeah. Can we do a keyword search? Yeah, let's do it. Can you look for social security? I mean, we have predefined searches for social security numbers, IP address, credit card numbers, dates. You're gonna do search a file. Here we go. Yeah. All the search results that contain the word search. Now let's do a predefined search. Let's go back to try previous. Keyword search. Let's search for IP. Yep. We got one. There we go. The hell is that? I don't know. Pretty cool. Oh, let's do an analyze of C. Search for CC. Oh, now we don't get anything. New search, do we have anything with date? Oh yeah. See, where is it actually located on the physical disk as well? So yeah, we have just uncovered quite a lot more files than we originally saw. Alright. So, I think we actually have a good love of pictures here. What about this thing called Foremost? What is Foremost? Alright. I used to give presentation to law enforcement as well. This is a talk I did many years ago. There you go. investigations and incident response using Backtrack at the High Technology Crime Investigation Association, New England chapter, September 22nd, 2009. Backtrack is now known as Kali Linux. I wrote this many years ago now. Hard to believe it's over 10 years. Backtrack is now known as Kali Linux. DCFL-DD is still around, actually. It's a version of DD created by the Department of Defense Cyber Forensics Lab. It calculates the hash of a disk on the fly. One of the things that you don't get with DD is feedback. So you're only going to get feedback when you either Control C or one finishes copying bit by bit copy of a disk, which can take like a long time. Has a status bar as well too. Yay. DD_rescue is a version of DD that actually deals with corrupted disk corruption. Yeah, one of my favorite tools. Foremost, yes. Foremost is also created, developed by the Department of Defense, Cyber Forensics Lab. It is used for what is called file carving and recovery. You can use it to just carve out all the pictures of a disk. So an example of I use Foremost is, here you go, search for all the JPEGs, skipping the first 100 blocks is Foremost minus S, 100 minus T, JPEG. Okay, so I don't need this anymore. Let's close out. Close the host, close the case. I think we can close the case. We got nothing left. We're going to go to the main menu. We're good. Now we hit Control C. Sudo apt install Foremost. We already installed it, so man, Foremost. What Foremost is to recover files using the header, footers, and data structures. Synopsis, recover file, yeah. Okay. So I have evidence.dmg here. So if I want to rip out all the JPEG, I'll do Foremost okay here. S100 minus T. Let's rip out all the JPEGs from evidence.dmg. Minus I. And enter. That was it. Ooh, there's an output folder here. Let's take a look what that is. Let me do a open folder. Output. Ooh, what's this audit file? Audit. Foremost found 1, 2, 3, 4, 5. 5 JPEGs. Look at all the JPEGs. Pretty cool. Okay, ripped out all the JPEG. Alright, let's do the PNGs. And let's do an RM minus RF output. Okay, nice. Output. Audit. It's only one PNG. Boom. Okay. Why do operating systems not default to more secure deletes? Is the reason speed or is it something else? Reason is speed. If you securely delete a file, it does take a lot longer. And a lot more writes as well too. It's a very good question. Has there ever been an answer on that? here it is. Deletion. Why didn't OS securely delete files right from... let's take a look. Right from the beginning. Take a look. I've never seen this. You're the first one, RZ, that I've ever asked the question in the history of this course and stream, for that matter. After decades of hearing that delete does not really delete to make that data impossible, that delete does not really make the data impossible to recover, I have to ask, why did the OS was not corrected long ago? Why the big deal? Can't the system just trundle along and the background overwrite? Okay, here it is. Early OS were written by programmers and for programmers. Anyone who programs and knows what pointers understand that deleting a pointer does not really do that they're separate. Okay, this is a really bizarre answer. This is a really interesting conversation. The modern operating system abstracts a lot of things from you. You no longer need to be a computer expert. That's correct. Okay? The price you pay is that these abstractions are leaky, that there isn't a fundamental disconnect that can be bridged. Okay? Here it is. Here's another take on it. There's a performance, following reason. Performance. It takes up the resources destroying a file. Imagine an application that uses hundreds of thousands. That's very true. What happened, and we have deleted like bundles that have like 10,000 files. It'll be a huge operation to secure. Yeah, okay, that makes sense. Extra wear and tear on the drive. So end done is also correct. Right cycle. I still don't know I still wonder who you are in real life. I wonder if you're a student or not in the course. This is not a complaint. It's just a comment. Sometimes the ability to retrieve a file is a feature of the operating system. Okay, all right. Sometimes this physical storage mechanism is abstracted from the operating system. There you go. Is Foremost Unix utility like Netcat, or do I need to install it like Nmap? You need to install it like Nmap. You absolutely, it's one of those very niche tools. Yeah, that's a great question. Ding 10K. Yeah. If I do a search for Kali Linux Foremost, here it is. Foremost, here it is. Foremost, a forensic program to recover lost files based on the headers, footers, and internal data structures. Yeah. It's also really small, 100 kilobyte. You gotta install on your own. Can you install on the Mac? Hold on. Info Foremost. Yep. There you go. Any viewers? Great question. You gotta install it on it. It's a very niche program. Very niche. Okay. That's all I got for demo, but is there anything else? Yeah, a bot. Yeah, what we're gonna do is something called ban. Hello, bot. Yeah. So what is this thing called incident handling? Incident handling is a very general and broad term. Incident handling really is the prevention of barking up the wrong tree. Is not just limited to criminal investigations, loosely speaking. But incident handling is forensics falls also under the umbrella of incident handling. Why is incident handling important? It's barking up the wrong trees, chaos, dead-end investigation, legal issues, cost overruns. And the incident handle all the time, like phishing. One of the things I've learned is be careful, like getting law enforcement involved in cases, because if you get them involved, they want to overtake the entire thing. So sometimes just going straight to the route of forensics is not the best idea. Forensics usually involve law enforcement. But if you have incidents that's like phishing scams that's all going around, you gotta have a process for that stuff. But the difference between incident handling and forensics boils to forensics is actually really, really grounded. It's like um, answering the who, what, when, where, why. That's the most important thing. No more fluff. Who, what, when, where, why, how. Incident handling is generally speaking is much broader. You got to be well versed with many, many facets of IT, information security, and also technology as well. Okay, uh, like forensics, there is a process. Um, the phases of incident handling are preparation, identification, containment of the incident, eradication, recovery, and also lessons learned. Now, that being said, if you want to learn more about incident handling, definitely take the SANS Institute Hacker Tool Techniques, Exploits, and Incident Handling course. It's not cheap, but what if I told you this? What if I told you that yours truly is an alum of the course? Yeah, you're truly is an alum of the course back in 2007. It's also certification as well too. Yeah, I kid you not. Want to also say that boot camp? Yeah, don't. I mean, I went to boot camp myself. I went to this. I'm an alum of this course. I'm an alum of the SANS Institute. The SANS Institute, what they offer is, and I mean world class training in security. If you want the best security training, some of the best training money can buy, world class and famous trainers, go to the SANS Institute. They're not cheap, but um, you'll learn a hell of a lot. Um, I took this back in 2017. I got a discount. I mean, they're pretty generous with discount, especially if you're in education. So this course actually, help you skills conduct incident response investigation. Yada yada yada. So let's take a look at what you will learn. The syllabus. The goal of modern and on-premise systems is to prevent compromise, but the reality is that detection and response are critical. Keep your organization and breach headline depend on how well incidents are handled to minimize loss to the company. Take a look at the syllabus. Uh, the first day. It's a 1 week course, 9 to 5 for 1 week, in person. The final day is, you'll see, it will be a capture the flag game. So day one is in response and cyber investigation. You'll learn about case studies, Windows investigation, PowerShell, enumerating Windows, network investigation. This is all day one. Malware investigation, assessing attacker malware in a safe test environment. Yep, another bot. Hold on, Global Achilles, I'll answer your question in some gory details. Ooh, day two. You'll learn hacker techniques you could use to conduct reconnaissance as a pre-attack step. Let's say exercises. Bite a foot. Networking on host scanning with Nmap. And you've already done that. Maneuvering shadow cloud targets with mass scans. Some of these things that should look very familiar. Day two. Day three. Password access attacks. Guessing with Hydra. Password cracking with John. Think you've done that in this class? Password cracking with Hashcat. Day three. Yeah. Day four. Public facing and drive-by attacks. Command injection, SQL injection, cross-site scripting. Very interesting, huh? Day four. day 5, Metasploit, hijacking. Yeah, and then the last game is a capture the flag game. We actually have we play capture the flag. So how much is this damn course now? Training and pricing. Holy shit. 8,275. Okay. So not cheap. I guess inflation caught up. Anyway, yeah. So I was an alum of this course, and you all got a lot of content I learned from this class. Like 504. A lot of students in this class actually have taken. They have a malware class. Where the hell is it? Courses. Um, Full course list. The malware course. Yeah, a lot of former students, take the reverse engineering malware analysis tools and techniques. Oh, Lenny's teaching it. Cool. There's also a capture the flag. Like everything is captured. Like the last day is capture the flag. Malware analysis fundamentals. Reversing malicious code. Malware analysis. No malware analysis tournament. Thing. $8,000. Okay. So if you want world-class boot camp training for security, go to SANS. Department of Defense sends their people to SANS all the time. So I'm going to answer Global Achilles' question, which is how important are certificates to getting a job or promotion in security? The answer is it depends. It really depends. Don't get too caught up on certification. I remember in around 2007, 2008, I was struggling and I was beating myself up to say, should I get the CISSP? The CISSP is a very general and very broad cybersecurity certification. It's also very expensive. It's like one's $500 to take it, but then you have to pay $100 each year to renew it. And I remembered I was asking people, but I think the best response I ever got from someone was, ask yourself, do you need it? The answer is it really depends on different places. Now, if you are going to be working for, let's say, like the Department of Defense, you actually need certifications. In fact, for your interest, Global Achilles, I have a gift for you. The hell is it? I know I've written it. Aha! On cybersecurity certifications in grad school. Here, Global Achilles, here you go. This is all for you, my friend. Here, I'm going to say certification, the bottom line is this: certification can only help you, not hurt you. Okay? Here, do you need a cert? So for some jobs, certification are required. For example, if you're working in the Department of Defense, I hope please tell me this is not a broken link. This is not a broken link. This is not a broken, it's still around. Here is the baseline certifications for the different job levels. So if you're going to do upper management, if you want to do upper management and security, it basically, I wouldn't say a de facto standard, but it is strongly recommended to get the CISSP. So for some jobs, especially if you're going to be working at the Department of Defense, certifications are required. I got the SAN GCIH certification back in 2007. A certification lasts for 4 years, and then after 4 years, you have to retake it again. I didn't retake it. I didn't need it. I would say that, getting a certificate helped me in some ways, You know, it was part of my bio, my biography at speaking engagements and stuff. Um, but otherwise, it didn't help me. It didn't help. I have never renewed it. I just let the certificate expire. But yeah, there are jobs that are actually that require it. So I hate to bring this topic up. So I'm not gonna name names, but I know that a lot of female, and let's be honest. Just say, I'm gonna say it straight out. Is that biases and discrimination? That shit still happens. I have a couple of friends that told me because they were women, they felt like, you know, I had to take an extra step to prove that I'm not pulling anyone's leg and that I'm really interested in security. So they got a certification, and it can only help them. I mean, yeah, I got a certification because certainly that was like the extra step because that helped me to get the job. Because, people just don't believe that, oh yeah, women are interested in security. I hear that I mean, I've heard that on a number of occasions. So, a certification can only help you, not hurt you. So I've even heard cases of that. So, does that answer your question, Global Achilles? Also, not every security certification is different. CISSP is broad. Things like anything by SANS is usually technical, very technical. Um, they're also not cheap as well too. A lot of the more recent students, they take the Security Plus exam because, hey, it's a certification. Oh, it is also affordable too. So if I ever have to quit my job, I actually have something in my back pocket to show. Security Plus is a real popular one, especially for recent grads. Because it's actually affordable. It's not like, oh, $500 and a renewal fee each and every year. And so that's that. All right. So that's all I have today. I think it ties in really well. So we did forensics today. We used DD. We used sleuth kit and autopsy. We used foremost. We introduced you to the SANS Institute. I hope you got a lot out of today. Oh yes, and of course we actually proved that there were more than. We finally showed. This is the real closing of the course. Is I showed how to actually recover for deleted files off of a disk. So we are good. Now, folks, thanks for tuning in. We are down to one last Twitch stream next Thursday. And I just want to give you a warning. It is not going to end well. Yeah. All right, folks. You've been great to me this year. Thank you so much. Yeah, it's cold out there, folks. Don't need this anymore. Don't need this. Thank you so much for everything. See you next week. Thanks for everything, folks. Take care now.